How's it going?
Alright.
Been a while, sir.
Yes, it has. It's been a very long 2 weeks. Very long. It's ridiculous because I never had it in the first place.
Oh, gosh.
I was just around somebody that had it, and I got 2 tests done, and I came back and used it. It's ridiculous.
Well, it is better to be safe than sorry, I guess.
Oh yeah, yeah. I mean, I respect that definitely.
But kind of a hassle for you.
Yeah, I didn't take Zoom. Most of my classes, a couple of my classes don't even have Zoom. So, like, I'm way behind in those classes. I've been reading chapters out of the book, but it's not the same thing as class.
That's just not right, man.
Yeah,
I thought everybody was supposed to have Zoom sections this semester.
my microeconomics and my business classes all have Zoom.
Hmm.
So,
Well, how are you feeling about this class? And did you get the review that I sent out on Friday?
I believe so. I just got this, the YouTube.
Yeah, I just sent that link out. Because I do have some people who are in the same boat you were in, and they're having to quarantine.
Okay. Yeah, Gen 1 reviews.
Good, good, good. That, of course, will be Friday.
Okay. This review, is this something we have to do and turn back in, or is it just for us to?
Yes, it is for a grade.
When is it due?
Friday. Alright, let's go ahead and get started. So, last week, we were talking about data will usually fit some kind of model. And it just really depends on what kind of data you have. The most basic model that might fit is a linear model. So, we were saying that maybe we have some data and it's scattered around when we graph it, but we can see that there's a trend going on here with this data, and that is that it is increasing, and it's increasing in this case at kind of a steep angle, so it's increasing pretty quickly. So what we can say about this is that as x increases, so as we go further and farther along on this x-axis, y is going to be increasing as well, and it's going to be increasing at quite a high pace. Now, that's about all we can say about just this data, how it's graphed like that. And so we said, well, there is kind of a line emerging here that most of the data follows. Now, not all the data is exactly on this line, but it follows it relatively well. And this line right here is what we would call a linear model. A model is something that we use to kind of understand the overall behavior of data and even predict some data that we might not have quite yet. So what we were doing last week is we were taking a model and then using it to get data. So remember that our model for a linear function is y equals b sub 1 x plus b sub o. And so what we were doing with this was we had a model that we could use, and then we were plugging in values for x and then getting things out for y, just seeing what y came out to be. Okay? Now what we want to do is go the opposite direction. Instead of using a model to get data, we want to use data to find a model. So fit a set of data to a particular model. Again, not all data fits a linear model. It's just that this is a pretty basic one, and it's a good place to start. So how do we do this? Well, again, last week we had b sub 1 and b sub 0, and we're using that to get x and y. This time we're going to be using x and y and getting b sub 1 and b sub 0. So the first thing we need is the r value, which, if we remember, has quite a long function, n times the sum of xy minus the sum of x times the sum of y, all over the square root of n times the sum of x squared minus the sum of x and then squared times n times the sum of y squared minus the sum, not 5, the sum of y then squared. And so we did this one day by hand, and it took us an entire class period to do. That's just the first thing we need. Of course, we also need b sub 1 and b sub 0. R just tells us how well this fits, and actually r squared is what tells us how well our data fits to our model. Okay? And I should note that r squared will always be somewhere between 0 and 1. 0 meaning that there is absolutely no fit, no correlation, and 1 meaning that it has perfect fit. Now, are we ever going to have exactly 0 or exactly 1 in a real life case? No. It's going to be somewhere between 0 and 1. But the closer it is to 1, the better the model fits to our data. Okay? So how do we find B sub 1? It's also got a formula. Thank goodness it's not anywhere near as beastly as this thing. It is the sum of x minus x bar times y minus y bar over the sum of x minus x bar squared.
What's the bar mean again?
Bar means mean. So for x bar, that is the mean of all of our x values. Y bar is the mean of all of our y values. So for this one, we would find the mean of our x values and the mean of our y values. And then like here, we would take each of our x values and subtract the mean of those x values. And we do that for each and every one of those. Same thing with y. We would take our y values and subtract the mean for y from each one of them. We sum and multiply. This one is basically the same thing, but we square and then sum. Okay? Then we also need b sub 0, which thankfully is quite simple. It's y bar minus b sub 1 times x bar, or b sub 1 x bar. Okay? So these are the 4 things that we really want to have when we're trying to fit a linear model to our data. Okay, so again, R and R squared are going to help us understand how well our model fits. B sub 1 and B sub O are going to be the things that we actually use to create our model. Now, like I said, it took us an entire class period to calculate one of these. So now we've got to calculate this, and and we'll even square that thing. That's a lot of work, and I'm not sure we have enough time in a class period to do that. So we're going to be using a calculator for all this. And in fact, I believe we're at the point that Ms. Lamar wants us to use a calculator on this stuff during like a test or something like that. Okay? But we do still want you to understand what the equations are. However, like I said, we just don't have enough time to calculate these equations by hand at this point. So I'll show you how to use this calculator to calculate all of this at once. First, we need some data. So let's say we have, of course, x and y. Those are the 2 basic things we need for our linear function. And we have x values 1, 2, 3, 4, and 5. And then the y values are 1, 2, 1.3, 3.75, and 2.25. Okay? So we want to take this data and we want to give it to our calculator so that it can calculate these things for us. The calculator that we use in this class, let's see if I can bump the brightness up on this thing. Whoops. Here. I think that's as bright as it can go, actually. So the calculator we use for this class is the TI-84, And I have a box of them that I can lend out for us during tests. So if we ever need them, I'll pass them out to you. So just follow along with me as I go through this. The big thing is this button right here, stat. This is the button that we're going to be using quite a lot because it has all of our statistics calculations in it. But of course, before we can calculate anything, we need to put the data into here, and that's what we're going to do first. Edit is the first thing you come to when you hit stat, and that's asking for data. So go ahead and hit enter. Okay. And well, I've already got some data in here, so I need to get rid of that. Let me do that real quick, and I'll show you how to do that in a bit. Okay, sorry about that. So hit edit, and it brings you to this page that has a bunch of different lists. These lists are where we put our data into. So we have a list for X values, a list for Y values, a list for maybe frequencies, a bunch of different lists. And they're all called things like L1, L2, L3, L4, L5. The big thing is L1 is typically for X values, L2 is typically for Y values. The calculator is set up to use these as X values and Y values. Okay, so let's go ahead and put our X values in for list 1, or L1. So that's 1, 2, 3, 4, and 5. And then, of course, put our Y values in for list 2, or L2. 1, 2, 1.3, 3.75, and 2.25. Okay. So we've got all of our data into our calculator, and we can move on. It now has everything it needs to start calculating things. However, something that I think is kind of neat is we can look at our data in a graph, kind of like this with a scatter plot. We can actually make one of those right now. So what we do is we go to second. So second is kind of like a shift key on a keyboard. And then stat plot is this blue thing, blue button, blue label. And it brings up a list of plots that we can make. We're typically only going to need one plot, so we're going to do plot 1. Things you need to make sure are correct on this list are you need to have plot 1 on. You need to make sure that your X list is set to L1, like we said. X is L1. And same thing for Y. Y is L2. The rest of this should be fine. It's set to a scatter plot. This is just what kind of points it's going to show, and it's going to show them in blue. Okay. So now we can hit graph. Oops. Let me clear that off. Graph. But where are our data points? Well, the way that the calculator works is it only focuses on certain parts of its graph page at a time, so you have to tell it where to look to find those data points. So we hit zoom, and then there's a nifty button here called zoom stat. It zooms into whatever stat data points you put into the calculator. So we'll go ahead and hit enter. And it has found the stat points that we put in. Again, these are all of the X and Y values that we've put in, just placed on a graph. So like 1, 1 is right there, 2, 2, right there, 3, 1.3 is right there, so on and so forth. Okay? So now what we want to do is we want to find a model that will fit this data. But let's look at this data real quick. How closely grouped together is this? Is it really closely grouped? Is it like on one single line? Or is it kind of scattered all around and spread apart? Yeah, it's pretty scattered. So whatever model we come up with, it's going to be pretty difficult for that model to fit this data because it's so scattered and wide apart. And that should reflect in our R-squared value. But let's go ahead and find the values for this thing. So again, we're going to go back to stat. It already has all the data points we need, so we don't need to edit anything. We need to calc. We need to calculate. And there's lots and lots of really interesting things that we can calculate with our data, but for right now, We just want to focus on linear regression, AX plus B. Hit enter. It asks you, okay, which is your X list? It's list 1. Which is your Y list? It's list 2. We don't need a frequency list. We don't need a store. We just need to calculate. So we hit enter, and it calculates the 4 things that we need. Now, it says A and B. A is our B sub 1. B is our B sub 0. It's just showing them in a general form. So again, remember that our linear model is y equals b sub 1x plus b sub o. So our b sub 1 is this a value here, so 0.425. B sub o is the b value, 0.785. R squared and R are also listed here. That's our correlation coefficient and our, well, it's not called variance, so I don't remember the exact term for R squared, but it's R squared. And remember, R squared tells us how closely matched our model is to our data. So R squared is 0.393, and then R is 0.626. That should be 7, but whatever. It doesn't matter. Okay. So now we need to actually come up with our model. Our R squared tells us that our model is it close or far from our data? Remember, yeah, the closer to 1 it is, the better it fits. Because this is actually not very close to 1, it's not going to fit very well. But let's find our model anyway. Very good, by the way. Okay. So y equals, b sub 1 is 0.425 x, and then we have our b sub o, which is 0.785. And this right here is our model. This is what should fit the data. Okay? Now, again, we know from our R squared value, it's not going to fit very well. So let's take a look at it. Again, we have a graph here already with our data in it. So let's go ahead and put our model onto this graph as well so that we can compare visually how our data looks with our graph, with our model. So to put the model in, we hit y equals, and we just enter in this model. So 0.425 x plus 0.785, and hit graph. And so there's the line. There's the line of our model compared to our data. So again, does it fit very well? Not really. It does follow what the data is doing. It is increasing, and it's increasing at a rate of basically the same as our data. But there's quite a lot of distance between our data point and our line. So if we draw a vertical line from our data point to our model, it's quite a lot of distance there. I mean, the first one starts out pretty good, but from there it scatters more and more. So yeah, our R squared was correct. It doesn't fit very well. Any questions? Okay. So that being the case, let's take a look at some data that does fit pretty well. Now, before we get into another set of data, we really ought to reset our calculator, make sure everything's cleared out and ready for the next set of data. So first of all, our model, let's get rid of it. We just go to the model and then hit clear. That's done. Then we want to make sure that our data from the previous example is cleared out. So we want to hit clear list. this option right here. And it's asking us what list we want to clear. So remember we used L1 and L2. If we look here, we have dedicated buttons for L1 and L2 and L3 in all the lists. So we hit second L1 to tell it we want to clear that first list, give it a comma, second L2 to clear out the second list as well. And then we hit enter, it says all right, I did that, and we're ready to go for the next one. So, again, if we want to put in new data, we hit stat and edit, and it brings us back to our lists. So for my X's, I've got 40, 69, 64, 50, and 73. And for my Y's, I have 56, 73, 70, 63, and 70 again. Okay? So, we have our new data. We can exit out of that, but let's take a look at it. Let's see what the graph looks like. Second stat, plot. Go into plot 1. Make sure that it's set to the right stuff. So we have it set to on. X is still list 1, Y is still list 2. That's good. Everything looks fine. So let's hit graph. Where's our data? Zoom, yeah. Again, the calculator only looks at one place at a time in its graph. We have to tell it where to find that data we just put in. So we have to hit zoom, and then zoom to the stats. So all the stats stuff that we just put into it. And there's our data. Very good. All right. So this one, how closely grouped is this data? Is it all on one line, or is it scattered around like the last one? Yeah, it seems like it's all in one line. In fact, we could almost make a perfect line through all of these points right here. This one's kind of like a outlier, but the rest of these look pretty good. So we can maybe expect an R² value that's pretty close to 1. But let's go ahead and calculate that and see what we get. So back to stats, calculate, and then down to our linear regression. Again, AX plus B. Make sure that we have the correct lists. So X is list 1, Y is list 2. We don't need a frequency, we don't need store, just need to calculate. And it gives us our values. So let's copy them down. So our B sub 1 is which one? A, good. So that is 0.475. B sub O is which one? B. So that's 38.259. R², of course, is just R², and that's 0.911, and R equals 0.954. Okay, so looking at our R² value, does it seem like our model is going to fit pretty well or not very well? Yeah, pretty well. This is pretty close to 1. In fact, if we were to just round this to the nearest whole number, it'd be 1. So this is telling us that our model is probably going to fit pretty close. Okay, so let's go ahead and make our model. B sub 1 and B sub O. We have Y equals 0.475 X plus 38.259. Okay, so let's go ahead and see what that looks like. Y equals, let's see, 0.475 X plus 38.259. Graph that. And yeah, that model fits pretty well to our data, exactly as our R squared said it would. So if we look at this one compared to the other one, the data points are almost right on the line. In fact, some of them are even like barely touching. And there's not as much distance between them. Again, take a vertical line from your point and draw it to the model, and that's how much distance there is from the actual point to the predicted value. So what? So it fits. It fits very well. Now, do all of them fit exactly? No. And should you ever expect them to fit exactly in a real world situation? No. There's always going to be a little bit of variation. But in this case, we can look at this model and say it's actually probably going to be a decent prediction for our data. So we can use this model to understand, okay, like if I had data point here, it'd probably fall there, okay? I can understand the overall data very well with this b sub 1 and b sub 0. Any questions?
You said use the real world. What would you use for in the real world? Looks like a job. Would you use something like this?
Okay.
I'm genuinely curious.
So think about, well, you're in business, right? Okay. So one thing that you might need to do when you're with whatever company you're with, profit margins. Okay. So you have, how's a profit margin calculated? It's the capital versus the cost. So how much did you make? How much do you have in your company? What was the cost of having that in your company? Okay. Now, as time goes on, you're going to collect data values. So you'll have your costs for your company versus your profit. You have your X and your Y. And so over time, you want to be able to understand what that relationship between your cost and profit is as the years go by.
Right.
So you'd have your data, and it would probably look something like this. It's going to be scattered. It's not going to be exact on something. But if you can make a model that fits it pretty well, then you can predict in the future what your profit margins are probably going to look like if things continue the way that they are right now. Does that make sense?
Yes,
Sure. I mean, there's hundreds of different ways that you could use it. The example I'm actually looking at right here is from Hawks, and it says a statistics professor would like to build a model relating student scores on the first test to the scores on the second test. I mean, hey, that's something I might actually do. Okay. Any other questions? Yes. So it depends on what you are doing. For our purposes, Hawks will tell you how much to round it, first of all. But for our purposes, we're typically going to round it to 3 decimal places. Any other questions? All right. So, have any of y'all looked at the review yet that I sent out on Friday? No? Did we all get it at least?
Yeah.
Okay, good. Between now and Wednesday, what I want y'all to do is to open up that review and at least try all of them. You don't have to finish it. You don't have to turn it in. Of course, it is due Friday. But Wednesday, I want you to have at least tried all the questions so that if there's something that's giving you problems, or you're just not quite sure how to do it, or you just need help, Wednesday we'll be going over a version of that review so we can hopefully get everybody on the same page and get good grades on this test. Okay? So again, that's what I want you to do from now to Wednesday. Other than that, I think that will do it for today. So hope y'all have a good one.